Hey guys, I'm here back with another math video. Today we're doing a geometry problem created by Daniel Liu. It might not be original because it's sort of generic, but he made this problem, and so without further ado, let's do it. So, look at the problem, pause the video if you need to. Yeah, it seems easy at first, but it's actually not. So, pause the video if you need to, just look at it. Okay. So if you want the solution, first let's take a look at theta right here, and we notice that theta is acute. Okay, well first let's do something. Let's draw the center of the circle. Okay, so sorry, yeah, not too good. Okay. But then this is the center of the circle. This is the center of the universe, okay? And this is alpha, and this is beta, and maybe draw that. Let's say that okay, let's say that. So what's the average of alpha plus beta? Okay, so in case you are not familiar with the properties of circles, the average of alpha plus beta is actually theta, right here. This theta. And to see why this is, let's just do a proof. So let's just do a proof right here. And this is a long problem, guys, so be patient. Okay. So let's say this is A and B. So this is the circle. So what is this angle? This angle since this arc A's angle, this arc B's angle is an angle defined if you draw the arc from the center. So like let's say this is the center, you do this. And this is angle A, and this is angle B, arc A and B. The generic basic properties of the circle tells you that this is actually 1/2 A and 1/2 B. It's just some generic properties. If this is the center, and this is angle A and this is angle B, I don't want to draw it because it gets messy, but the properties of the circle show that since this is arc A and this is arc B, it's 1/2 A and 1/2 B. So since based on properties of exterior angles, you know this is angle theta. This other vertical angle is also angle theta, and since this angle is angle theta, it's the exterior angle to this triangle. So this theta is actually just 1/2 A plus 1/2 B, which is A plus B over 2. So A plus B over 2 equals theta. So the average of these two angles is theta. Knowing that, that's important. Let's just, for this proof to go on, let's move this pi slice over a bit. So it's snug right next to arc A. So this is arc B. So let's snug right next to arc A. This is angle beta. This might get a bit messy, so please follow along. We're gonna need this line, and we're gonna need this. So so first of all, what is this arc? This is arc A plus B, obviously. So this arc is A plus B. So this angle is A plus B. So what's this then? This is 360 minus, yeah, my drawing tablet's acting up. Sorry. 360 minus A minus B. So if this is 360 minus A plus B, then what is, here's a question, what is this angle right here? This angle of this triangle. Well, this, again, we basic geometry properties that we used here, this is 1/2 of this arc. So this angle is, since this arc is 360 minus A minus B, 1/2 this is going to be 180 minus A plus B over 2, which is actually equal to 180 minus theta, which is what we just proved. Okay, so if you've ever taken any basic trigonometry, you know that, let's say this arbitrary length is C. Let's say this arbitrary length is C. You would know that C squared equals A squared, and this is B. So a squared plus b squared minus 2ab cosine, and since this angle was confirmed 180 minus theta, 180 minus theta. Now again, this is a basic trigonometric formula, so I suggest you memorize it if you don't know it already. And also, what's interesting is that since we know theta to be acute, we know that this value is between 90 and 180. So okay, and since 180 minus theta is in this range, then a basic trigonometry function shows that 2ab cosine 180 minus theta is actually negative. So that's negative. Then c squared equals a squared plus b squared plus some arbitrary value, since negative and negative is positive. So since this, we don't really care what this value is, but I drew c right here. So as long as a plus b is not equal to 180, you should intuitively see that if it's less than 180, less than or equal to 180, it should be less than or equal to the diameter, because it can only get smaller, and this should be intuitive. And yeah, so as long as a plus b is not equal to 180, then this will always be less than the diameter. That should be intuitive. So c squared is less than or equal to d squared, which is the diameter. So a squared plus b squared plus some arbitrary value m is less than or equal to d squared, essentially, since c squared is less than d squared. If this is the case, then a squared plus b squared is less than or equal to d squared minus m, and thus it is very obvious that a squared plus b squared is less than or equal to d squared, since m is in there. So we just proved it, and thanks for watching, I guess. If you're a new viewer from Brilliant, be sure to subscribe to our math channel. We cover a wide variety of topics, and be sure to watch our past videos with Daniel and I. So thank you for watching.
Hi guys, it's Daniel here with another Math Points video. This one's going to be on the 2001 Amy. Amy 1, number 7. So, first, we see that we have a triangle ABC with lengths of 20, 21, and 22. We have 2 points D and E on AB and AC respectively, with DE parallel to BC and DE going through the incenter of ABC. And we want to find the length of DE. So first of all, let's just draw the angle bisectors. We can see that this is already drawn here. They're the dotted lines. And then since we have angle bisectors, that reminds us of the angle bisector